Hi, I'm Dr. Mary Lusk, and I'm an assistant professor in the Soil and Water Sciences Department at the Gulf Coast REC. Today I'm talking about sources of nutrients to Florida's water bodies. So nutrient pollution is a serious problem all throughout Florida, all throughout the United States, really everywhere in the world. Anywhere you have water and humans, we have the chance of nutrient pollution in those water bodies. And we're concerned about nutrient pollution because it's the nutrients, when they're in excess in our water bodies, can cause problems like you see in this picture here, the thick algal blooms. And the algal blooms can lead to a lot of other problems like health problems for humans, as well as fish kills and death of other aquatic wildlife. So just to make sure we're all on the same page when I start out here, when I speak of nutrient pollution, I'm talking primarily of having excess nitrogen and phosphorus in our water bodies. So nitrogen and phosphorus are both essential nutrients. They're needed by all living organisms on Earth. But when we have too much of them, it's a perfect example of too much of a good thing. And when we have too much of that in our water, that's when we see problems again, like those algal blooms that you saw on the previous slide. Nitrogen is commonly the biggest problem in our coastal waters in Florida when we have algal blooms, and phosphorus is usually the culprit for our freshwater lakes like Lake Okeechobee. So some of the goals of my research here at the Gulf Coast REC are to take a closer look at those nutrients that can cause those water quality problems, and to identify the sources of them and how they're moving in the environment and how humans are affecting those nutrients, and the management strategies that we need to adapt in order to prevent nutrient pollution of our water bodies. So we have a couple of different things that we work on in my lab, but when I work on water quality and nutrient issues, these are usually the big questions that I ask. I always like to give this slide when I'm giving presentations in the local area, in the Tampa Bay area, because this shows what we're dealing with in the Tampa Bay estuary. So the Tampa Bay estuary is impaired by excess nitrogen, and that excess nitrogen in the Tampa Bay estuary can cause problems like death of our seagrass, which is very important for the Tampa Bay estuary ecosystem. It can also lead to problems with algal growth, fish kills, eutrophication, which then leads to loss of our fishing and our tourism industries. So a couple of years ago, the Tampa Bay Estuary Program began studying sources of nitrogen to the Tampa Bay water body. And a couple of the sources that stand out here on this pie chart that I wanted to talk specifically about include, first of all, atmospheric deposition. So just 21% of the nitrogen that goes to Tampa Bay comes from rainfall. It's coming from the atmosphere. And this originates by vehicle emissions and industrial emissions like power plant emissions. All of those emissions have nitrogen in them. So it goes up into the air, and it's up there in the atmosphere, and it comes down with rainfall. Big source of nitrogen to Tampa Bay, 21%. The next thing I want to point out is that bottom part of the top pie chart where it says 63% stormwater runoff. More than half of the nitrogen that goes to Tampa Bay comes from stormwater runoff. And that's water that just flows over the landscape every time it rains, makes its way somehow to maybe a stormwater pond, and then from there it flows onward to a river, and from the river then it flows on to Tampa Bay estuary. Now that stormwater runoff can come from a lot of different sources. If you look down at the bottom of the pie chart, you see that 20% of that in our area is coming from residential sources. So these would be residential urban neighborhoods. Then we have a couple of other sources like undeveloped land, commercial and industrial, some agricultural uses. But I will always focus on that piece of the pie chart that's residential stormwater runoff. 20% of the nitrogen going to Tampa Bay from that category. And that's where we do a lot of our research in my lab. We focus on that residential runoff and things that urban residents can do on their own lawn, on their own property, to reduce that runoff and reduce the amount of nitrogen and phosphorus in that runoff. Here's just a quick little study. I'm going to take a few minutes to to summarize a quick little study that we recently published that was done in Florida to look at residential nutrient pollution. This study was done in a waterfront community in Florida. All of the homes sit on the water, and they have grass or turf grass that goes from the backyard all the way to the water's front. And we collected stormwater runoff from lawns in this community all throughout the year. And we wanted to compare nutrients, nitrogen and phosphorus, and that stormwater runoff during the dry season and during the rainy season. So the dry season being October to May and the wet season being June to September. We also wanted to see if there was an effect of the local fertilizer ordinance blackout period. So if you're not familiar with that, many places in Florida have a local fertilizer blackout period. During that time, you cannot apply urban turfgrass fertilizers to your lawn. That blackout period is usually from June to September during the rainy season, under the premise that rainy season rains flush out nutrients from the soil, and that if people are fertilizing, that's just going to be an extra source of nutrients that are just going to be flushed out with the rainy season rains. So we wanted to test if that ordinance is effective. So we have samples of runoff during the dry season when there is no blackout period in effect, and during the rainy season when that blackout period is in effect. Our first research question in this study was to compare nutrient concentrations in runoff from different landscape designs. And on the left side of this chart, you see FFL, that stands for Florida Friendly Landscaping. And on the right side, you see conventional. Those are conventional lawns. So the FFL lawns had Florida Friendly Landscaping principles throughout the lawn. They reduced turf. They used vegetation other than turf grass. The homeowners made a conscious effort to reduce fertilizer and pesticide inputs, and a couple of other Florida-friendly landscaping practices. The conventional lawns were just that. They were just nothing but turf grass, highly fertilized, lots of chemical inputs. So the data here, we're looking at NO3 in the blue, which is nitrate nitrogen, Ortho-P, which is phosphorus in red, and the orange bars are NH4 or ammonia nitrogen. No statistically significant differences between the two landscape types, although the conventional lawns did have a little bit higher phosphorus and ammonia nitrogen in their runoff. Our second research question was to evaluate the impact of the fertilizer ordinance blackout period. So in this data that's shown on this slide, we're looking at all lawns in the dry season versus the wet season. So again, remember the dry season, there is no fertilizer blackout enacted. People can apply whatever they want, whenever they want. In the wet season, we do have a blackout in effect. So no turf grass fertilizers can be applied during the wet season. In this case, we do see a statistically significant difference, particularly for the orange bar, which was ammonia nitrogen. We actually saw higher levels of ammonia nitrogen during the wet season and the runoff from those lawns than we did during the dry season. And that was surprising because it's contrary to the logic of the fertilizer ordinances. We were expecting that during the wet season, when people cannot apply fertilizer to their lawn, that we would see less nitrogen in the runoff, but we actually saw more ammonia nitrogen. And we hypothesize that the reason for that is because of legacy pools of nitrogen in the soils in those lawns. So in this case, we're not seeing any benefits of the fertilizer ordinance because during the rainy season, we're still getting lots of nutrients that are stored in the soils being washed out. They're not necessarily coming from fertilizer, they've just been sitting for some time in that soil. Our third research question was to compare the nitrogen isotopic signatures in our samples to known nitrogen sources. So, strange terms here, isotopic signatures. That's just like a fingerprint. It's a tool that we use to identify where nitrogen comes from. We analyze nitrogen in our samples and we look at that isotopic signature or that fingerprint and we compare it to known culprits or known sources of nitrogen. And in this case, we can compare it to known sources such as atmospheric deposition, again, nitrogen that just comes from rainfall, or maybe NO3 fertilizer, which would be nitrate fertilizers, or NH4, which would be ammonia fertilizers, or maybe soil pools, or maybe even pet waste. That can certainly be a source of nitrogen as well in residential landscapes. So on this chart, all the little squares and circles that you see represent a sample of runoff taken from one of our lawns in our residential neighborhood. And they plot in different places on this graph. Some of them clearly plot within the area of atmospheric deposition. Some of them clearly plot within the area that represents fertilizer. And some of them clearly plot within the area that says they're coming from pet waste. So basically, it just shows you that we have a lot of different sources contributing nitrogen to the runoff in this neighborhood. And I always like to tell the story of this study, how you'll notice there are a good number of points that plot in that pet waste category. We had a homeowner in this study who loved to tell us how they do not apply fertilizer to their lawn. They try really hard to be good environmental stewards of the water bodies around them. So they applied no chemical fertilizers. They do, however, have a beautiful black Labrador retriever that goes poop in the backyard. And guess what? They don't clean up after the beautiful black Labrador retriever. And so when we analyzed runoff from their backyard, where was all the nitrogen coming from? You got it. It was coming from the pet waste. And we were able to show that homeowner this data. And in this case, it was an easy fix, right? It was something that the homeowner could easily take care of just by beginning to pick up the pet waste. So just in summary, the research findings of that quick little study that I just showed you, sources of nitrogen were highly variable in this neighborhood and could not be attributed solely to landscape sources. Remember, just atmospheric deposition was a major contributing source. Pet waste was a large contributor. Soil nutrient pools may be masking benefits of the fertilizer ordinance. So just because we've put a fertilizer ordinance in place doesn't mean we're going to immediately see results in water quality. We need to remember that. And nutrient management needs to account for and consider all sources of nutrients in a landscape. I always make the argument that fertilizer ordinances may be a good first step, but they're not the magic bullet, and we need to realize that there's multiple sources of nutrients moving to our water bodies, and we need management that addresses all sources, not just one. All right, shifting gears just a little bit, I also do a lot of research on stormwater ponds with an eye of identifying ways that we can improve nutrient removal in those ponds in order to prevent nutrient pollution to larger water bodies like streams and estuaries and bays and our coastal waters. So stormwater flows into these ponds, and we assume that when it's in those ponds, something magical and wonderful happens and the nutrients get removed somehow. Unfortunately, there are many stormwater ponds in Florida. They are all in blue on this map. There are 76,000 stormwater ponds in Florida, actually. They represent about 1% of the state's land area. And research shows that at best, average nitrogen removal from stormwater ponds is only about 30 or 40%. Average phosphorus removal is a little bit better at about 70 or 80%, but we're not getting complete removal of either nitrogen or phosphorus in those ponds, and especially not getting very much removal of nitrogen. So one of the things that we're beginning to do some research on in my lab is how to improve the functioning of those ponds. And one of the things that we're really excited about right now is some research that we're starting on vegetation around those ponds to remove nutrients. Intuitively, it makes sense that if we have a buffer zone of aquatic vegetation and wetland plants, sort of in between the water and the turf grass zone. Like you can see in this picture here, intuitively it makes sense that the roots of those plants are going to take up some of those nutrients and help clean that water for us. But we really don't have much research on that. And so that's one of the things that we're starting to do some work on. And I'm really excited about that. We're really hoping that this will provide information that will help us to design these stormwater ponds in a smarter way so that we can remove more nitrogen and phosphorus from them. Okay, so that was me very quickly, some of the work that we're doing. We have many other things that we're working on, and I would love to share with you. If you'd like to talk more, feel free to reach out to me by email. My email address is here, as well as my Twitter. So thanks, everyone. Bye-bye.